So this is a good opportunity for me to say thank you to Intuit and some of the other folks who've been involved in making Argo Flux come together, including BlackRock and Amazon especially. But under that rather bland corporate umbrella, let me say thank you again to the actual engineers who've done all the work to make it possible. Thank you very much. It's easy for me and Pratik to stand up here and say, this is happening, but actually it turned out to be real work. Okay. So I'm going to say a little bit more about GitOps before we have a panel, and I'll talk about sort of quickly past, present, and future from my perspective as a Weaveworks independent software vendor. If you haven't heard of us, we are doing a lot of work around Kubernetes and GitOps. We sell an enterprise platform for solving problems with Kubernetes, ranging from installation to management to deployment of applications and progressive delivery, the whole GitOps stack, if you will. We're based in the US and the UK with people all around the world, a distributed team, a bit like most software companies nowadays, like GitLab and so on. And GitOps, the name, this is my fault, I'm very sorry. I went to speak to a friend and I said, we thought of this name GitOps for something that we've been doing. Do you think it's a good or bad thing to call things? And he said, dude, that is the ugliest name I've ever heard, and I can't unhear it. So I thought, this is good marketing. And we wrote blog posts about it starting about 2 years ago. You know, as Bob and Pratik have clarified, it's building on infrastructure as code and DevOps. You know, 90% of what we're talking about is not new, but there are some important developments, including the key one is we're not orchestrating change from outside the system anymore. We're letting tools like Kubernetes and Argo Flux drive the change from inside the system, which means that we can be secure, we can be completely natively integrated with everything, we can be automated, and all of that means that we can scale, and we can be correct at scale. And I became aware of this because our engineers started doing it. I think, interestingly, you know, Pratik was talking about Intuit's work deploying Kubernetes. At Weaveworks, we decided very early on, 4 or 5 years ago, to use Kubernetes. Kubernetes was launched within 7 days of Weaveworks launching as a company. And I remember bumping into Mark Shuttleworth, the CEO of Canonical, at an event. And he said, Alexis, what do you think about this Kubernetes thing? I think it's going to be huge. This is like 3 days after it was released. And Mark is a bit of a visionary. So I said, I think this is the stupidest name I've ever heard for a technology. And we'll never succeed. It's a typical Google mess. Anyway, here we all are. We realized quite early after that I was completely wrong. And in fact, this was going to be the right way for us to run a SaaS product. So we'd built application technology for container developers, writing apps using containers, and we wrote a SaaS product to help them manage and monitor it called Weave Cloud, which is part of our stack today. And we had to choose a technology to operate that stack, so we chose Kubernetes. And then we found that we had to operate the damn thing, which turned out to be much harder than we thought. And so the engineers built this system, and I wasn't really aware of how important this was until this particular moment shown on the slide. I'm sitting in the office doing an email or something very important like that. And we hear, you know, the sun is shining, it's a lovely day, and then one person in the corner says, I think if I press this button, I'm going to wipe out everything. So then we go into sort of Matrix-style slow motion. I start standing up from my chair saying, don't do that, and there's a click. And then there's an oh afterwards. And then the team went into crisis mode and got everything back up again in 45 minutes, which at the time was quite fast for us. And now we can do it much more quickly. And I said to the team afterwards, what did we do there? That seemed like a pretty cool thing. Why was it so organized? And how do we know that we can get back into the right place? And they explained to me that what they built was a system where, using infrastructure as code and tools like Terraform and Kubernetes and Docker, immutable things, they had created an entire source of truth for everything that we were running, including all the backups, all the multiple zones, all the different versions of it, dev and production. And not just the running clusters, but also the apps, the services, how the network was wired up, how we were monitoring things, how the dashboards worked. And every time they made a change to one or more parts of the system, that was an atomic update in the source of truth, which was living in Git, so that all of the changes could be applied atomically and therefore correctly in the running system whenever we wanted, which meant that when we had a complete cluster, then everything was repairable because we had a reproducible system based on our source of truth. And you can't do this just with Kubernetes. You need some other pieces as well. Pratik mentioned the Argo toolchain, and we wrote Flux. And Stefan, who's going to demo later, wrote Flagger, which does progressive delivery, and other tools as well. And we found, as Pratik did, that people wanted to use this. So we started giving away the dog food. And now Flux is a CNCF project. And I hope that with Argo coming together with Flux, CNCF will be a fantastic home for a large-scale industry collaboration here. And here's a quote from when Flux joined the CNCF, really hammering home the point. It's about a single source of truth for everything in your system. And so what's the benefit to you, end users? Well, and also contributors, I hope. We're creating a standard tool chain for GitOps that everybody can use, so we don't have confusion about which tool is best. We had parallel evolution of very similar approaches, like the octopus eye phenomenon. You know that story, the human eye and the octopus eye are almost the same design, but they evolved completely independently. So we can do that in technology, except we can also go one step further and bring things together. And the first joint project there is the GitOps engine, which is going to be the back end for the future pieces of this. Other parts of the future include progressive delivery, which Bob mentioned. Again, there'll be a demo of this later. The great thing with progressive delivery is you can think in terms of, I've got 1,000 clusters running 2,000 microservices, and today I'm running 3,000 A/B tests on different aspects of that across my team of 700 developers. Now, that might sound like complete science fiction, but that is what people will actually be doing very, very soon with these technologies, because you will be able to specify in a coordinated manner all the different things that you want to test across all of your clusters. And this will mean that you can federate across your whole teams all those experiments and changes so that people can try out many, many different things very quickly and iterate on all your online services and backends very, very fast. So this will mean that your ability to meet customer needs is greatly improved. So putting that into a little timeline, for me, at least from Weaveworks' side, I feel this is very much an evolution. And the next step, which I'll talk about in a minute, we'll talk about these profiles for larger scale platforms and templating. But joining forces with Argo, with the help of Amazon and BlackRock, for us is an evolutionary and very, very exciting step. So I mentioned clusters just now, and Pratik also talked about clusters. The GitOps model, shown here as a sort of diagram, is very powerful and generic. You can do it for machines with tools like Terraform, virtual machines with something called Ignite that we created, clusters with Kubernetes, applications and services with the Argo toolchain. Can you also do this for clusters themselves? And let's talk about what that would mean. With GitOps, one of the things that we get is we get a beautiful Git-based workflow. Now, if you don't like using Git, that's fine. You can use one of the many front-end sugary tools that sit in front of it. But underlying it, you're still using Git as a system of record, source of truth, for transactional updates to your description of your state. And then integrating that with various different places where things are running. In this particular picture, we're showing an example of deploying things from Elastic Container Repository to, registry to EKS. What if I said, I do this for whole stacks? So why is this important? When I talk to customers and I say, what are you using Kubernetes for? Is it useful? Is it easy? They say, well, it's pretty good now. I can go to EKS or Azure or GKE, and I can ask for a cluster, and I can have a cluster. But what I really want is I want my application team to be productive immediately, which means maybe they might say, I want to have a machine learning cluster ready for machine learning, or I want to have a mobile app cluster ready for my mobile backend, or I want to have a big data cluster or another cluster or another cluster. So how do we do this? And how do we make it something which, if I give you a machine learning cluster, I know that we can manage changes for that. We can do upgrades, we can do patches, security, everything like in Pratik's demo, but for that machine learning cluster. And we can also always answer these key questions. And if you can't answer these questions, give us a call. Do you know if your cluster's in the correct state? And can you always reproduce it whenever you want, at will? And can you cleanly upgrade it? So that using GitOps would let us do that. So what do we have to do to give people whole platform-ready, app-ready clusters? And the answer is, there's quite a lot of things we have to do. Jeepers. You know, we have to get a core cluster. We have to add components to it, like wire it up to networks and storage and load balancers. And if we're running in the cloud, connect it up to specific backend services. Then we have to deploy apps to it. We have to coordinate wiring up them to things like, you know, Lambda if we're on Amazon, RDS, et cetera. And then we have to verify that's correct. And then we can operate and manage it. That's a lot of things. And imagine doing that at scale. And what we don't want to do is be in a world where every time we create one of these clusters, it's only the person who built it who can fix it, operate it, and manage it. Then we have pets, or even worse, snowflake clusters, which become, you know, these kind of grand things that require whole teams to just keep up and running. What we really want is cattle clusters that we can start and stop at will. So what we're working on now is reproducible clusters using GitOps. And the way we're doing it is we're taking Flux, now Argo Flux, and we're applying that to cluster management. Now, the way that Argo and Flux work is if you're deploying an app, you have a description of the app, and then you use that so that Flux tells Kubernetes, hey, this is what the app should be doing. And Kubernetes says, aha, I need to deploy a new app, or I need to make an update, like add a, you know, start some more containers, or deploy these things. Let's do that for the whole cluster, which means that we need to have how it's wired with networks and storage, the list of nodes, what core applications we're adding. So let's say in my machine learning example, I might need to add Kubeflow. Now, if you've used Kubeflow, you'll know that deploying it is not a simple thing. You need to go through a certain set of steps in a specific order. So we have to conceal that inside the description as well. And then if we do that right, we've got that developer workflow. We just make pull requests to create one of these clusters or to manage it. So we're running it. We say, this machine learning cluster needs another 1,000 nodes. We change the config. It immediately will get another 1,000 nodes in production. So that would be pretty cool. And if we could do that, then we could do this, which is we could build any stack we like in a reproducible, safe, fast way, easily, just based on models of those stacks, which means that we could run it wherever Kubernetes supports model-based deployment. And I'll show you what that means in just a moment. For example, as shown in this picture, on EKS, or on tools like Firecube, which is an open source thing that you can run to do testing for EKS. And then on top of that, you can have your profiles, your models. So you want to do your ML ops, your machine learning ops, great. You just deploy that profile. You want to do a Cloud Foundry build pack or Heroku build pack, we can do that too. And here's how it works. We have something called an EKS controller. Now, if you haven't seen it, we wrote a tool called EKS-CTL, which I highly recommend that you have a look at. It's Amazon's recommended way, or one of the recommended ways for running EKS. So that's now integrated with Flux, so that based on descriptions of the clusters, the controller can apply them to the running EKS clusters, which means that if you're running EKS, in one step, you can have a complete web environment, or a quick start profile, as we call it. And then that is managed for you based on descriptions. And here's a cool thing. The same technique works for open source too. So we can do our testing on our laptops or on-prem, and sometimes if we have a hybrid environment like EKS plus on-prem, we can deal with it in a single, safe, coordinated, model-based way. And here's what those look like. And those of you who've been up close to the world of Kubernetes will know that this is a cluster API spec, something that's been coming through the community the last couple of years, which we've been integrating into tools like EKS Control and the open source equivalent for on-prem. And this is a description of a cluster. This one in particular is an EKS cluster with node groups for auto-scaling. So if you were using one of these, then you'd auto-magically have your EKS clusters that do this. And because this is safe and always correct, we can do this for thousands of clusters if we want to. We can scale, which is awesome. And just to add, if you're one of the many people in the room who's thinking, I don't want to have to edit YAML files, I agree. Don't worry. We'll get better at solving that problem very soon. But this is the underlying machine language of all of your future fleet. And so just to recap, we're driving things from a controller. It's a GitOps controller. It uses Flux to join Git to the cluster and then make sure that the changes are applied correctly. We have these concept of profiles or models, like an app dev one, and we deploy workloads that way on top, which ends up with this simple workflow that looks a bit like this. And if you're a Helm person, it all works with Helm, don't worry, as well. And so just to recap, we end up with this world where instead of thinking about low-level things like clusters, we think about models for different use cases: machine learning, build packs, web apps, mobile apps, whatever you like. If you're in finance or telco, there might be finance apps or telco apps. Now, if you found that interesting and you want to talk later, come and talk to us at our booth. We've got a product stack that deals with these issues. And here are some screenshots. I'm not going to do a demo like Pratik did, but you can sort of see similar things. Dashboards for your clusters, different models here, machine learning in production, and other choices that you can make. And here's my favorite, which is showing you the GitOps diffs. So when you're using GitOps to do all your management of your clusters, one of the really cool things is you can be told if you've drifted from your correct state, no matter what you are running. I run into countless customers who say, I can't do this, which means I never know if I'm in the right state. With GitOps, we can bake that entire awareness into the cluster. So it gives you a much simpler model for alerting, at least on things that we can predict. And we can do progressive delivery this way, too. It's not just for static environments, but also fast-moving environments. My colleague Stefan will give a demo at noon today here, a progressive delivery based on GitOps, using this apparently, well, it looks a little bit complicated in the diagram, but essentially, we're driving canaries automatically by granting orchestration of the canary to an agent running inside Kubernetes for you, which means that I can say things like, across these 15 clusters, roll out this canary and direct 15% of the traffic to it, and if I see these metrics, I can carry on going, and if I see those metrics, I can roll back, which is the baseline for those experiments that are so valuable that you will need as you go into the future. Which gives you, just to wrap up, a set of tools that you can use for progressive delivery, and as you can see, the key payoff in relation to the profiles and models that I talked about is there in the middle. If we want to do this, we can just say, give me the profile for my canaries. And it'll load it in, and then you're all set. So you don't need to think hard about this diagram. What you need to do is write one single line of code, and then you've loaded up all the things you need to do it. So that's where GitOps is heading in terms of simplifying the user experience for you with these new features and cool things. Thank you very much.